Good morning, students. So now let me discuss with what the problems I have already given. I think you have already copied. I have sent it in the Google Classroom. Now let us discuss one or two of those problems that I have sent to you. So here, how to find the formula for sigma k of n. By sigma k of n, we mean the sum of the kth powers of the divisors of n. So by definition here, sigma k of n is a sum of the kth power of the divisors of n, where d runs over the divisor of n. So if you have n here, n is a product of p1 to the power e1, p2 to the power e2, dash dash pr to the power er, where E1 here, EI is greater than equal to 1. So means n is a product of distinct prime powers P1, P2, P1, P2 and so on. PR are distinct primes. Then what we need to find is what is sigma k. So therefore here sigma k of n, according to the definition, it is sigma k of p1 to the power e1, p2 to the power e2 dash dash pr to the power er. But we know that sigma k is a multiplicative function. So if it is a multiplicative function, so this can be written as sigma k of p1 to the power e1 into sigma k of p2 to the power e2 dash dash sigma r of pr to the power er. And the reason is since sigma k is a multiplicative function. By multiplicative function is whenever GCD of mn is equal to 1, then sigma k of mn is same as sigma m k of m into sigma k of n. So this can be written as product of sigma k of pi to the power ei, where I varies from 1 to r. So this product sigma k of p1 to the power e1 sigma dash dash stands for, instead of writing all this, we can write it as product of this pi of sigma k of pi to the power ei. This pi stands for the product of all this sigma k of p1 to the power e1 dash dash sigma r of pr to the power er. Now the divisors of pi to the power ei, where I varies from 1 to r. What are the divisors of pi to the power ei? They are 1 always divide this, and then pi square dash dash pi to the power ei. So we have sigma k of pi. Let us find what is sigma k of pi to the power ei. This is equal to the sum of the kth power, because according to definition, it is sum of the kth powers of the divisors of n. So here these are all the divisors of n. So it will be 1 to the power k plus pi to the power k plus pi square to the power k, pi to the power k, pi to the power k the whole square plus pi to the power k the whole raised to 3 plus dash dash plus pi to the power k the whole raised to ei. So this is according to formula, it is pi to the power k the whole raised to ei plus 1 minus 1 divided by pi to the power k minus 1. So this implies that sigma k, so we have sigma k of pi to the power ei is equal to pi to the power k the whole raised to ei plus 1 minus 1 divided by pi to the power k minus 1. But what is sigma k of n? It is product of this. So sigma k of n is equal to product of this whole thing, pi to the power k the whole raised to ei plus 1 minus 1 divided by pi to the power k minus 1. So this is the formula for sigma k of n, where n is expressed as a product of distinct prime powers. Okay, that is this one. So next is proof that if GCD of, next question, if GCD of AB is greater than 1, then tau of AB is less than tau of A into tau of B. Now this is the sum of the divisors of AB. Sorry, there is no comma here. Tau of AB is less than tau A into tau of B. So here That is, the sum of the divisors of AB is less than the sum of the divisors of A into the sum of the divisors of B. Number of divisors, not the sum of divisors. So here solution, let G here stands for the GCD of A and B, or we can say that G stands for, the notation for GCD is, we express it in this form, and suppose it is greater than 1. So tau of AB here, sorry, there is no comma, tau of AB here will be equal to summation by adding 1 to each divisor, where D runs over the divisor of AB, and according to definition, tau of A also will be summation of 1, D runs over the divisor of A, we add 1 to each divisors, and then tau of B, summation of 1, where D runs over the divisor of B. So this is according to definition of the sum of the divisors, a number of divisors of A and B. Next, if you have, let us write A here is equal to P1 to power alpha 1, P2 to power alpha 2 dash dash PR to power alpha R, alpha I is greater than equal to 0, and G and B here is equal to P1 to the power beta 1, P2 to the power beta 2 dash dash PR to the power beta R. Why we express A, B as a product of prime powers, are distinct prime powers? Because here they are the GCD of AB. Had it been that the GCD of AB is equal to 1, then they don't have any common factors. But since, according to the question, the GCD of AB is greater than 1, means they have common divisors among A and B, they have common divisors. And we write it as G to be the common divisors of A and B. So let us take G to be this one, P1 to power delta 1, P2 to the greatest common divisor among this A and B, P2 to power delta 2 dash dash PR to power delta R, where delta I here is nothing but the minimum of among this, the minimum of these powers of A and B, that is minimum of alpha I and beta I. So therefore AB here, multiply AB, you'll get, it is P1 to power alpha 1 plus beta 1, P2 to power alpha 2 plus beta 2 dash dash PR to power alpha R plus beta R. So therefore tau of AB, which is equal to, according to the definition of this sum of the number of divisors of AB, it is defined as by adding 1 alpha 1 beta 1 plus 1, just like in the case if n is equal to P1 to power E1, P2 to power E2 dash dash PR to power ER, then tau of n here, which is equal, since tau is a multiplicative function, it is tau of P1 to the power E1, tau of P2 to power E2 dash dash tau of PR to power ER. So this is equal to, but tau here it is E1 plus 1. So here instead of E1 we have alpha 1 plus beta 1, and then we add 1, so we have this result. So into alpha R plus beta R plus 1, which is nothing but product of alpha I plus beta I plus 1, where I varies from 1 to R. Now next, let us find tau of A. Tau of A, it is tau of P1 to power alpha 1, P2 to power alpha 2 dash dash PR to power alpha R, and we know that tau is multiplicative function. This is tau of P1 to power alpha 1 into tau of P2 to power alpha 2 dash dash tau of PR to power alpha R. And this is equal to, by formula, it is tau, it is alpha 1 plus 1 into alpha 2 plus 1 dash dash alpha R plus 1, which is nothing but product of alpha I plus 1, where I varies from 1 to R. Similarly with tau of B also, I can write it as product of beta I plus 1, where I varies from 1 to R. Now you have alpha 1 I plus 1. Now alpha I plus 1 into beta I plus 1 minus alpha I plus beta I plus 1. This is equal to, you multiply it, is alpha I beta I plus alpha I plus beta I plus 1 minus alpha I minus beta I. And from here this will cancel, and then 1 also, there is minus 1 here also. So what remains here is alpha I beta I, and this is greater than or equal to, this is strictly greater than 0, because the GCD of A and B here, the GCD of A and B is greater than 1, so therefore this power alpha I beta I, they are strictly greater than 0. So here, so as GCD of A and B is equal to G, and these are true for and this is greater than 1. So among this alpha I beta I, there are some of them which are true for all I. So therefore tau of AB will be into tau of B here. As you can see here, tau of, this is if you apply product on each of this, you have tau of A into tau of B minus tau of AB is greater than, this implies that tau of A into tau of B is greater, minus tau of AB is greater than 0. So if it is greater than 0, this implies that tau of AB is strictly less than tau of A. Just take one of this to the left hand side, right hand side, so you have tau of A, less than tau of A into tau of B. I hope it is clear to you.